Hello again, everybody. Today we're going to start talking about parallelograms. Use relationships among sides, angles, and diagonals to talk about the interesting properties of parallelograms. Okay, there are a lot of ways that they're similar. There are unique relationships between opposite sides, opposite angles, consecutive angles, and diagonals that are all very unique whenever we have a parallelogram. Of course, a parallelogram is we'll define it here in just a second. We're coming out of Pearson section 6.2 anyway, and there's the vocab we're going to get into. Parallelograms, opposite sides, opposite angles, and consecutive angles. So let's start with a parallelogram is a quadrilateral with both pairs of opposite sides being parallel. So this is one side, its opposite side must be parallel to it. Same with what we got over here. One side with a parallel opposite side. Both pairs of opposite sides must be parallel. That makes it a parallelogram. Interesting properties now. Okay. First of all, we can abbreviate it with a little parallelogram symbol there. So this is ABCD. It is abbreviated as parallelogram ABCD. A and B, as you notice, AB and CD are opposite sides. So are AD and BC. Okay. Opposite angles. A and C would be opposite angles. Or let's mark the angles actually. Okay. So are B and D, opposite angles. All right. Now, consecutive angles would be next to each other. Okay. So A and D would make consecutive angles. Okay, that's what we call that. So would A and B would be consecutive angles. All right, so you guys get the pattern there. Okay, any angles next to each other are called consecutive. Okay, so first theorem, interesting property about parallelograms. All right, if it's a parallelogram, you know what? Opposite sides will be congruent. Okay, plain and simple. If it's a parallelogram, opposite sides have to be congruent. Both pairs of opposite sides will be congruent. Good? Good. Next, just so you don't forget about proofs, I've thrown one in here just to prove how we know that, okay? So if we're given a parallelogram, we're going to prove that the opposite sides are congruent. All right? Well, we are given, we got a parallelogram. By definition, sides are parallel, opposite sides are parallel. Okay? Now, that means, checking out, parallel line, transversal, and I should have drawn that a little prettier, but let's try again. Parallel line, another parallel line. Here's a transversal. Okay, look at these angles 1 and 4 are alternate interior angles, right? Check out this other set of parallel lines. The same transversal. Angles 3 and 2 are also alternate interior angles. Therefore, since the lines are parallel, these must be congruent. Okay, so with that pattern, congruent, 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 reflexive. We have two triangles that are then congruent by ASA, and then it also tells us, of course, that the parts AB must be congruent to CD, and BC must be congruent to AD by CPCTC. All right? That's how that's how we would prove that. I'm not going to do the proofs on the rest of them for the purpose of the video. In fact, some of them may show up on your homework, but we have everything we need to prove all of the upcoming theorems, all right? So theorem 6.3, just to summarize, if it's a parallelogram, opposite sides are congruent. Theorem 6.4, if it's a parallelogram, then you know what? Consecutive angles have to be supplementary. A plus B are consecutive, they add up to 180. Okay, Same with B plus C, have to add up to 180. Same with any other pair of consecutive angles. CD add up to 180, so do AD. So, by the way, when you prove that, we're going to want you thinking about those same side interior angle relationships, okay? Parallel lines cut by a transversal, same side interior angles have to add up to 180. Okay, Theorem 6.5. If a quadrilateral is a parallelogram, then opposite angles have to be congruent. All right? If it's a parallelogram, A and C are congruent, so are B and D. Opposite angles must be congruent. Next, Theorem 6.6. If a quadrilateral is a parallelogram, then its diagonals bisect each other. Here's our picture. I draw the diagonals. They are each cut in half. AE is congruent to EC. BE is congruent to ED because this point here is the bisector for each of the two lines, two diagonals. Okay. So, one example of a way we might use this, what are KM and LN? All right, given this information, knowing that it's a parallelogram. Okay, so how are we going to use this information? Well, pause for a second, think it through, click start when you're ready. And here we go. I know from the last theorem, diagonals must bisect each other. If the diagonals bisect each other, that means that this part x must be equal to y plus 2, one formula. And this part, y plus 10, must equal 2x minus 8, second formula. Okay? So set that back, move it out of the way again. All right, so we got a system of equations. All right, x equals y plus 2 and y plus 10 equals 2x plus 8. So I'm going to substitute. I'm just going to take this and put it in place of that in a substitution step right here. Okay, and let me do this the easy way now. Notations. So when I do my substitution step, I get this. Distribute the 2, combine like terms, subtract or add the 4 and subtract the y. You can follow through the math at your own pace here. And we find out y equals 14. Plug that into this equation here, and we find out that x must be 16. All right? Finishing off the problem, because it didn't ask what is x and y, it asked what is km and what is ln. Let's plug them in. So kp is y plus 10, must be 24. PM is 2x plus 8, also 24. Makes sense that they would have to be congruent too, right? But that makes km have to equal 48. Okay, we're also going to plug it in for x and y plus 2. Okay, Pn must be 16. Of course, x already we found out was 16. Ln must be 16 plus 16 or 32. Okay, so make sure that you understand where we went with that so that you can do it on your own, okay? Moving on. Another theorem that they throw in this chapter because it comes in handy on doing some proofs, but really doesn't have anything to do with parallelograms. But anyway, if 3 or more parallel lines, like I got going on right here, here, and here, 3 parallel lines, if they cut one transversal into congruent parts, then any other transversal will be cut into also congruent parts. Not necessarily congruent to this one, but congruent to each other across that transversal. So an example of what you're going to do with that, I got parallel lines, and I'm told that AB is congruent to BC is congruent to CD, and I'm told that EF is 7. Well, what is EH? Pause. Answer coming now. All right. Since all that stuff is true, if this is 7, if it cuts, if our parallel lines cut these, want to do that. If our parallel lines cut these sections into congruent parts, they also cut these into congruent parts. So if this is 7, this is 7, this is 7, EH equals 21. All right, have fun with this, and I will see you next time I see you.